Hello. Morning.
Hey, good morning, Kevin. The recording is on.
Oh, hi, Kevin. Hi, Stephen.
Morning. Hello.
Yeah, morning.
Your note taker joined before you.
Oh, really?
Yeah.
Oh, it only works for 30 minutes,
Yeah, I
Oh,
have the recording is already on. So I think, yeah.
so it should be okay. Yeah.
the free version is only 30 minutes.
Yeah, because the free version.
I don't know how to get the Gemini note taking work.
They might make you pay for a better subscription.
But the event is created on the dev calendar. I thought that should be automatic because the dev calendar account has a premium.
I don't see. I've been trying to figure that out. People kept on trying to tell me that, but like the dev calendar doesn't have an account. You know what I mean? Like it's just a calendar. There's no account.
Tyler did here.
Hello.
Hi, everyone.
Oh, hi, good morning.
Hey, Tyler, we're just talking about how does the Gemini note take works. This event is created on the dev calendar. It's the recording is already on because I joined. Once I enabled the auto recording. Once I joined, the recording is on, but I don't know how the Gemini note take.
Yeah, I promised Kevin to spend the time for that. The issue is currently for Gemini, the workspace, the features, we should have a paid account. I can, the Google can support the paid account, but the only issue is that whoever create the meeting, they use their own account. This is the issue.
Oh, I see. I need to switch that account, Google account also.
Yeah, either way, someone should create that things. I was figuring out that the creating the workspace which include all of the PMCs. Let me spend today the little bit more time. The 2 Friday ago, the 2 weeks ago, I spent time to figure out how we can add them. Then we can add all of the PMC's email, and whoever created in the PMC side, we can have the Google Meet and the Gemini.
Got it now. Thank you.
Did you create this meeting using the calendar, or did you create it yourself?
I create myself, but on the dev calendar.
Yeah, you actually have to create using the dev calendar. Like there's a way to do that, and then you get all the functionality. But hopefully Talat can figure out this whole thing.
Yeah, I didn't know that. Was there any shared account to create the meetings?
So when you create a new, like Stephen, you should have access. So when you create a new meeting, you can switch to the dev calendar and create it using the dev calendar, and then you should get all the functionality, I believe.
Could you include me also to like temporary? Then I can test it, without you guys.
Yeah, we can do that.
Okay.
I can try to see if I can do it after the meeting.
Okay, sounds
cool. I think it's 5 minutes past, so let's get started. Last time when we were meeting, since we had several people asking for specific examples for the indexes we are planning to do. And I already mentioned there that the goal here is to create a framework for storing the indexes. So don't look at these examples that the sole ones which we would like to implement, or even maybe not the exact ones we want to implement. So feel free to modify, change, and propose your own stuff. I just collected a few of them which might have a different characteristics, so we can it can drive our discussions here. If you take a look at the document, let me try to share it. Okay. I went through these example use cases, added it to the document. Later we can remove those if we decide a different one or don't want to that into in the top part of the document. But here it is now. One of the examples I put there is the primary key index. When we were talking with Steven, we were thinking about the ways how we can improve on Flink CDC ingestion, how we can remove the needs for the equality deletes. And in this case, what we found that would be very, very useful is having an available index which starts from the primary key and points to the actual file name and position of the primary key in the data files. So based on this, if we have a primary key which is updated, we just would use this index and actually get the file name position there and convert it immediately to delete vector or a delete value in a value in a delete vector. I don't go into the details how it would be used in a sense because it's really, really complicated. The thing is that this one would be used for when we are restarting a Flink job. We will need to get all of the primary keys and file name positions from a given table and store it in a Flink state or somewhere else. Make it keep it up to date with the new updates and new inserts and new deletes. And it would be nice to write out from time to time. We don't really want to write out it with every commit. At least my understanding. By my understanding, we don't really want to update it in every commit, but from time to time, don't want to update those. We don't want. So if we are doing on the primary key, then there are other queries which are not running from the primary key, which really won't able to benefit from other layouts. So every reader of the table can just really effectively read based on primary keys. So if I would like to read using the country or using whatever else, then we are out of luck. If I see Ryan's comments on there.
So what is there I know this is the use cases of primary key index, but there's no requirement that we have only one of these and it must be a primary key, right?
Pardon?
Or is it the cardinality for a given key? I'm just thinking like if you have a delete use case, this would be really effective, right? Because you could say, go find all the records matching this from the index and then create, DVs directly off of the index, merge those. Is it that we would, is it that we only want a single value in this for a given key? Or could we actually have multiple values for a given key? So like, what is the primary example of a primary key that we know identifies a row? So for example, like if I have a generated UID for a user, but that user also has a email address, right? I could delete users by email address as a GDPR sort of concern.
Yeah.
I could have indexes on both primary key, my UID, as well as that email address. That would be perfectly valid to keep both indexes. And then it seems perfectly valid to, extend that to other columns for secondary indexes.
Yeah, basically, this is just a specific example. I didn't want to cover all of this index cases. So the ask was that come up with the specific use cases we would like to cover. This one was the one which were struggled with Steven quite a while to find a good way to not restrict the layout of the table, but still provide a way to quickly resolve primary keys to delete vectors in time.
Okay. So we are open to those other use cases as well.
Absolutely. Sorry, Stephen, go ahead.
Yeah, just a quick follow-up. I think in the Flink, the equality is actually like primary key. That's why we're kind of talking in a primary key concept. Yeah.
Yeah. Okay.
I see Prashant.
Yeah. So one question on this front is that the guarantees to keep secondary index in sync versus primary index in sync might be too different, right? I mean, we need to make sure that after every write, the primary key is consistent. It can't lag behind. Otherwise, we'll have to fail writes in a sense that suppose my index is lagging behind, it still needs to be covered. Then when a delete comes in and my index is not at sync with the, let's say, a most up-to-date data snapshot, then we might have to fail that write. But in secondary index, I think we are okay to let it be a little bit out of sync. Like coming from Dynamo world, it's known that the indexes are supposed to lag behind when they are being asynchronously updated. So I just wonder that indexing framework might require two different guarantees when thinking about primary index and thinking about secondary index. Like any thoughts on that front?
Okay, so basically this specific example doesn't really require us to have an up-to-date index in this case, because this index is mostly used for actually reading when the job is restarting. Then we will read the current state of the table, and if the index is not really up-to-date, we still can do a read up from the changes after that and update the index to get a current value. I think this situation it's easily applicable for most of the indexes. It has diminishing results depending on how old is the index given compared to the current one. And I have been thinking quite a lot about synchronously updated indexes, and I found that very, very hard to make it happen because of the constraints we have on how to commit and what do we want to add it to the commit.
Yeah, I think all the indexes are just recommended. If it's out of sync, we should not use it.
Then?
So, yeah, kind of, in line with the question about like synchronous versus asynchronous. I agree the synchronous is difficult to do, but also are we making kind of assumptions here, and are they reasonable to say usually when you're using a index like this, you have single writer as opposed to multiple writers producing data? Because like if you think about the primary key index in the Flink use case, like it's almost always going to be the case the Flink is the only writer and the only one updating that index, barring like the background maintenance question, right?
And deletes.
Yeah, and which is like why I think like the maintenance question around indexes does matter. But at the same, yeah, okay, good point. Like deletes, if people are like coming in specifically and doing deletes, I would think a CDC case that probably wouldn't happen. But it's just like once you get into the question of like conflict detection, especially with these, like you could be rewriting significant portions of the index every single time you write. And then like the conflict detection and everything else gets much harder when you're thinking about multiple writers. So then, what does that mean in terms of like the asynchronous nature and the responsibility of whoever is maintaining the index to either account for these other writers who may not know about the index, right? Because otherwise we're looping everybody into the right requirements for indexes. So like, oh, maintenance needs to know how to handle it, and like individual like delete calls need to know how to handle the index. Like, I'm just, is it reasonable to assume we have single writer for these cases? Is it reasonable to assume that like, or do we need to define like whether these other activities would really hurt the index in a way that could then like render them almost insufficient for what we're actually trying to do?
I would be very hesitant to put any pressure on the writers that you need to do this or do that for a table which has indexes. For me, it is actually a secondary data added to the table which helps queries if it helps. But I would like to separate those out. Ryan?
So I'm wondering, do we have just a place where if you have a single writer scenario and that single writer needs to update the index synchronously, that, I mean, do we just have a property of the index that says this is a synchronously updated index? If you can't update the index or you don't intend to update the index, don't update the index. I think that that would be very reasonable. There are also some index updates that, I mean, whether we allow false positives in the index. So if you're deleting rows, you could say, hey, you might get you might get a position for a deleted row. And that would be reasonable as well, to allow some background processing to take place. That would also mean that you basically only need to index or update the index for additional rows, which would be nice. Anyway, like I think that there are ways to take care of this in the format where we don't need to specify all indexes are asynchronous or all indexes are synchronous. We can say, depending on your use case, you can block at the table level and say, look, if you're not going to update the index, don't touch this table, because there's a Flink process that cannot go and re-index your entire table if you do a big merge operation. I think that that would be reasonable, but in most cases, you don't need to do that. Prashant, I would also push on your characterization of primary versus secondary indexes. I don't think we have primary indexes, right? We might have an index on a primary key. We might have a, you know, index on something else, but those two things are just a type of index that may be updated synchronously or asynchronously. And then the table itself has its layout. So like layout and primary index are usually sort of interchangeable, but I don't think we're saying we're going to change the layout or add more strict indexing properties to the layout. Right. And that's why I think this is just purely a secondary index discussion.
I just want to briefly respond to the question about the asynchronous versus synchronous and commit. Like, I think the implementation, specifically REST, I think it's actually very easy for us to accommodate both synchronous type commits and asynchronous type commits. I think the question is really just about like, what expectation are we putting on writers who are participating against tables that have indexes? So you can definitely have a writer that synchronously commits its index. But I think the bigger question is like, do we need to create some sort of construct for other writers so that they know about it, whether they can participate or not? And that, I'm hesitant to open that door.
I think there are use cases where the index is useless unless other writers participate.
Can we just put that on the catalog though? Because then the catalog could be the one enforcing whether somebody can actually do a commit without an index update or not, as opposed to defining it in the spec and then levying a requirement against writers that has to be, you know, supported everywhere.
So yes, we could. I think that means, I mean, that's really, I'm thinking about this from a requirements standpoint, not a implementation or how do we achieve this standpoint. So maybe we decide based on the structure of indexes that that is the most reasonable way to do it, that it's a catalog responsibility to deny commits. The only downside I see there is the catalog could deny a commit for a, you know, well-meaning writer that's done a lot of work. So it is really nice if the client participates, because it can prevent them from, you know, going and running a large merge operation on a table and then failing because it doesn't contain a index update.
Yeah, I agree with that. And I'm not only looking at it from an implementation standpoint. What I don't want to do is like have something that loops in all writers to being required to handle indexes. I'm concerned about that, and like what I'm trying to avoid having to add that requirement.
But isn't it reasonable to say that I don't want writers? I mean, so however you enforce it, whether it's client side and the index referenced by the table says you have to update this synchronously, or if it's the catalog making that decision, either way, you're failing writes that attempt to write to that table, and you're levying the same requirements on the writers.
Yeah, but
that if they want to write to this table, they have to support index rights.
Yeah, but clients could also interrogate. It isn't necessarily like if they know that there's an index and they can't support it, they could still fail. Does that need to be a requirement or not? I think that's an open question. Like we need to.
I think in terms of pushing implementations to support index rights, it's identical, right? Whether you tell the client ahead of time or enforce it at the service. Like if there is a requirement anywhere in the system, in order for a given client implementation to update that table, it has to support indexing.
Stephen.
Yeah, I just want to add a little more on the one writer that Dan and Ryan mentioned. So when I was working with Peter on the Flink equality, right? Initially, we were thinking about a lot of complexity, how to handle concurrent modification with between the Flink job and the compaction job. It just gets really, really complicated. So later on, we kind of want to pivot into, hey, let's move the compaction into the Flink. We're already doing that maintenance so that we can use the lock within the Flink to avoid concurrent modification. That can simplify a lot of things. So yeah, basically have just one Flink job right into the table will make things a lot simpler. So yeah, and the Flink job may synchronously update the primary key index potentially, yeah. So yeah, I think that concurrent modification with indexing is just so complicated.
Okay, Todd.
I just maybe I'm not clear for that. Even though we have a one writer, the user can create a different columns index, right? And basically we cannot shuffle the data across the writer, the worker's writer. And it doesn't mean that all of them will come to the single commit. And which means that we always have a multi-writer scenario.
So I think basically we will have to support asynchronously updatable indexes. What we are talking about here is either if we want or can support synchronously updatable indexes, and if in this case, what requirements shall we put on the writers for these, and what we can and what we cannot enforce. And I think I understand. I agree with Ryan that in some index types it is very, very useful to have synchronously updated indexes for the table, and if we can make it work somehow to commit along with the table method commits, that would be a nice addition to that. On the other hand, but I have seen indexes as, until now they are mostly something which could be done asynchronously or should be done asynchronously given the size of the table and the data stored in Iceberg tables. Okay. Any more questions around this? Okay. And another index I added to the document is the secondary data layout. It's basically just a situation where you have different queries running on the table, which are benefiting from different data layout. So we currently have the primary layout of the table, which is nice for a given set of queries, but very often we are much better off if we have a kind of duplicated version or a duplicated version for some of the columns of the table, which helps us by the, for example, if the source store table is ordered by order ID, then we have joins which are way more effective than if it's ordered by timestamp or something else. And if we can duplicate some of the data or part of the data, we pay the cost on maintenance, we pay the cost on storage. But if the table is not fast changing too fast, then it often works to do this. We can either use a different query plan if the engine can see that we have a different layout, or even behind the scenes, we might be able to use a swapping of the data files. So instead of reading the original table files, if the index contains all of the columns which are in the query, and in organized in a way which is better suited for the returning the results, we can return the index data files instead of the data files of the original table.
So Peter, here you just talk about secondary index, right? Secondary key index.
Yes.
Give a key without the row positions.
I guess my question here is this similar enough to the previous index type and the next index type that we have real things that we can do?
Pardon?
So is this
Index implementation is different, if you are saying it.
right? But so I mean, yeah, we have multiple different like types of indexes, right? So we've got the, you know, sort of position, like where is the corresponding row index? Then this is, I think, a covering index, right? And then there's a vector index as the next one, and planning index, or, you know, I think that's essentially a skipping index. Are we saying that these are all similar enough that we can use the same mechanism to track and maintain them? Like, what is the overlap in scope here?
Okay, so I think we can. The overarching scope is the metadata first. So how we store the metadata for an indexes, we should decide on. I think we should decide on first on that, and then we can start thinking about how to implement specific indexes. To be honest, if I look at these kind of indexes, if I look far enough, they could be implemented some like materialized views or like materialized views behind the table. And all of, so if you look at the primary key index, this primary key and the two specific metadata column. If you look at this index, you choose specific columns for the table to store in your materialized views and partitions those on the correct partition keys or clustered by your better different clustering specification, and store the columns there which could be participate in the queries which are using that. And also, if you look at the vector index, the IVF PQ vector index, this is a specific type of vector index, is actually again something which is UDF. With a UDF, you can convert the vector to a quantized value, and and you can partition it by centroids, and basically you get an IVF PQ index, which is again kind of like a materialized view, and you can do the first implementation that, and you can use either as a materialized view, or you can, if your engine it knows better, then it can use as for more effective results.
So if I'm understanding Ryan's question correctly, and I have a similar question, mostly about the first two types, because I know less about the vector index and like what we would really be tracking there. But what is fundamentally the difference between a secondary index that only has one column and is sorted on that column, which would be almost equivalent to the primary key index, right? Because we're saying that like, well, you know, the primary key is actually just a special type of this secondary index that is very narrowly focused for one particular use case. So
Okay.
like, without getting into the
I'm coming from that
like,
direction.
something like what are the,
yeah, are these things similar enough that we want as the same mechanism for them? How similar are they? Like, yeah, to Dan's point, this could be a primary key index, or sorry, the first like
First two
position index, the first position index thing might just be a like a second index type with only metadata columns, file, and position. And then you could easily say like, well, hey, if I have a query where I'm like, you know, sum of whatever attribute when ID is in this set, like if I had that attribute in my index, I could just, you know, calculate that aggregation. So are these two basically the same things with, you know, column copies in them or not? But then that comes down to the maintenance, the representation, and things like that. So I guess I think we understand at least those two use cases. Maybe we should just cover the use cases first because I'm just getting ahead of us.
Yeah. So basically, I'm try to collect the use cases. I didn't try to provide the solution at this point because last time when we had the discussion, basically everybody was asking that, okay, but what is the use case, how we will use these indexes, because that will help us find an approach which is generic enough and we can use it. So basically the use cases are a bit different, I think, try to be different, but actually the technical solution behind them is, I agree with you that it is something which could be similar. Question?
I have one question regarding using columns as given values inside indexes and how they're stitched back to the table when we are actually reading the table. For example, like column defaults and stuff like that, they are just schema updates. If I understand correctly, if I add a column default or something like that, those things, like the way we stitch it back, maybe this is an implementation only question, but we need to think about that things if we consider index table as the source of truth for the column values as well. So one thing that comes
very good point. Let me write it down. I think I already took half of the meeting, and Huashin has another very specific example for the indexes. So I think, Huashin, if you want to move forward, and we can talk about that. What do you think, guys? Is it okay with you? Okay, Huashin, go ahead, please.
Okay. So last time when we had a sync, I think the most people are asking for the Bloom index. The question is how to prove the Bloom index can have a performance gain. I think that for the Bloom index, it is not designed to fit all the cases. It will only have a performance gain for a special case, which is that it has a very high cardinality, and also because when the cardinality is very high, the normal statistics like mean and max is not very useful. So it's kind of trying to find a needle in the haystack. So the Bloom index is only helpful in this case. So is this fair?
Well, sorting can also be helpful, but we just, hey, you may sorting some primary query column, but you still need to use Bloom filter in for other columns, high cardinality column also.
Yeah, I think we know, I agree that Bloom filter is useful or is limited to cases where you have extremely high cardinality and you cannot organize or you cannot use that column in the layout of the table, right? So like if you had some ID column that you were bucketing and sorting by, you wouldn't want to use this, which I think just makes it a secondary index, right? Because if you were able to use the layout of the table, that would kind of be this quasi primary index that we usually think about. I think where Bloom filter kind of comes into question for me is if we're designing like a index with yes or no, like does this row exist in the table results, is there space for a Bloom filter index to be useful? Or should we go the extra mile and say, like, we're just gonna copy all the primary keys? And so the analysis of, you know, what kind of cardinality do you have to have before like the actual primary, sorry, not primary, but like before that ID based index is no longer useful? You know, what kind of queries, how do we maintain the size of the Bloom filters? Because I'm skeptical of Bloom filters in general because it's very difficult to design around their sizing requirements. So if you have a Bloom filter for, you know, a given number of distinct values and you overfill it by 2x, I think your false positive rate goes up by like 10x. I forget the exact numbers, but it was something along those lines. And so it's very sensitive to overfilling. It's also because it's a false positive rate, you get false positives. And so if your false positive rate is like 5% and you have an inquiry with 10 elements, you basically are only able to eliminate half of the files in the table from that filter. So like, I think there are those limitations, and like, I'm curious, is there this sweet spot where Bloom filters are significantly smaller and really fit the need compared to a position index that would satisfy the first requirement here, or first use case?
I think Ryan covered most of my comments already, but I agree. I'm very concerned that like Bloom filters tend to be shooting for a very narrow gap because it combines both like the physical layout properties, like how many values am I stuffing in a parquet file, along with, you know, like the size of the Bloom filter and, you know, how you configure each one of those to get a hit rate that is reasonable for any given query. And you may end up, even with all that combined, doing worse than taking advantage of something else like a secondary index where you're actually copying the values, or just doing something more aggressive like sorting the table based on those fields. And so it's one of these things that it's very hard to hit that sweet spot. And I would love to see, you know, the math around it to confirm or support like these things, but like there are so many different variables that affect the quality of the Bloom filtering, and it's hard to control for all of those in just like a general case. Back to Ryan, more problems probably.
Actually, no, I would say that the question that all of this brings up is, when do Bloom filters work? And I think we clearly know cases when Bloom filters do work. And I think that we should use that as a way to think about this. So Bloom filters tend to work in the file case, right? I have a known NDV size, and I can size the Bloom filter exactly to the number of elements I'm using, right? So the Bloom filter is for a specific set of records. At that point though, right, then you have to manage, how do I handle a Bloom filter for every chunk of records? And how does that chunk of records like interop with the table itself. This is why I think embedding Bloom filters in Parquet files, as long as you tune your false positive rate, can be really beneficial. But again, it requires tuning, and then you're essentially storing, you know, a Bloom filter per file. And that really just means that we have better filtering at the task level for, hey, do I need to run this task or not? And there, like, eliminating 50% of your tasks and just not doing the work after you do an initial Bloom filter scan can be super valuable. But my skepticism comes from, how do we do that at the table level without this very large explosion in like Bloom filter? Like, because if we just do a Bloom filter to file, map, then we're essentially just moving where the Bloom filter is and not parallelizing that work as much. So like, I think it really comes down to, yeah, what is the structure of this, and how do you deal with the issues of overfilling Bloom filters, managing lots of Bloom filters if you're right sizing each Bloom filter to a specific set of records? How do you deal with that change over time? And then like, how do you deal with tuning and false positive rate?
So if we can somehow find out the Bloom filter can prune 50% of the file, then it should be beneficial, right?
Yes, but I mean, then it becomes a question of, is this something that we should be doing at the file level or at the table metadata level? Because I think you've got to overcome the like, Bloom filters at the file actually work better, because then we can go start a task, read the Bloom filter, eliminate the file, and end the task. Versus like, do we want to actually do this at job planning time on the driver or coordinator node?
If we can skip lots of file, for example, 50%, I think it's, more beneficial to do it in the planning phase, right? Because
it would be, but then like, if the amount of data you have to read is a Bloom filter per file, then that's very different than like the index where you take all of the IDs and you bucket them and sort them, and you can skip through that index. So is there a mechanism by which we can skip through a Bloom filter index? Right? Like maybe bucketing and then doing a Bloom filter. But again, like, I think that I'm just trying to lay out things that we have to overcome for this to be valuable.
I would actually say that like the IOs in the planning phase is net worse than the IOs in the task phase, right? Because typically planning is done more localized. And so you're shoving a lot of IOs to consume the Bloom filters into the driver or whatever is doing the planning process. And without distributing that, then you end up stacking a lot of IOs in the planning phase. And so, skipping early is better. But at some point, if you're doing a lot of operations, you need to distribute that. And so it's a net wash between task phase and planning phase at that point.
What if we turn out distributed planning?
Well, now you're just doing it in the same place you do the tasks, right? So it's net equivalent. You're just doing it before you do the task. And in that case, it's actually worse because you're doing 2 IOs for anything that you do touch. Whereas if you're doing it as part of the task phase, you can skip any of the early IO. It's just like, I'm not sure that that's a convincing argument, that it's better in this scenario to do it in the planning phase.
So is there a concrete design that can be analyzed for these issues? Because like, I think I'm just trying to lay out like my skepticism of Bloom filters as an index type. And I thought for the purpose of this document, we're saying like, hey, all these things kind of look similar. And I think there's an argument that they do look similar. They can be maintained in a similar way, but I'm not sure that that also includes the Bloom filters, because the index data has to be aggregated into chunks and is large. So like if we might be talking past one another because we're saying this is hard to do in general and not thinking of a specific plan and design, and you might be thinking of a specific plan and design.
Okay, Stephen.
Yeah, I think definitely one point where so to make Bloomfield work effectively, we may have to do a few extra things. For example, we talk about distributed planning, right? And also, if we just store the Bloomfield like a one Puffin file per data file, then that's same as the Pocket footer. But if we can organize those Bloomfield index, let's say, align with the manifest file boundary, maybe the distributed planning can be effective. I would distribute the manifest to tasks, do the planning, do the pruning, and come back. Then we can maybe eliminate 95% of the data file with Bloomfield. But that definitely a lot more complexity to do that. And I think also, one question Brian brought up is the second index was Bloomfield. Yeah, we haven't discussed that last time. Last time we only talking about comparing Bloomfield index versus Pocket footer solution. But yeah, this second index comparison is definitely the question to also consider.
I think we will need to put the Bloomfield in different shards instead of having a huge Puffin file. So it's easier for incremental update.
So is the idea that you basically aggregate file level Bloom filters across files into larger Bloom filters?
Oh, that's into some Puffin file.
Into some Puffin file. So for example, you might have a Bloom filter for a partition to see like, hey, is it in this partition? And then you could use that to select I guess if there is a concrete design in mind, maybe we should talk through that and then see how that aligns with the secondary index stuff here.
Yeah, that's good idea. I think the aggregate them, for example, at the manifest file level might be a good boundary.
And by the way, like the answer could honestly be like, there's a doc here linked for secondary indexes. I have not had time to review that doc. And if the answer is, Ryan, go read that doc and come back more informed, that's totally fine.
I don't think that we have that kind of doc. Yeah.
Okay, just a quick idea. We are talking about what if we store the in a Puffin file for every manifest file, and then when the planner goes through, if we have distributed reads, for example, then distributed planning, then anyone who reads the manifest file could decide to read the Puffin file, and only that planner part should read that manifest file, Puffin file. And then the question is, maybe it is like a column family statistics for Puffin for Bloom filters.
Column family. Are you talking about file group or talking about column family?
So you remember we had a discussion when we separate out the data files to separate column families, and if we decide that Bloom filters could be a column which resides its own column family, and it is connected to the manifest file, then every reader could decide either read the actual column or not read the actual column, and can decide to actually apply the stuff in during the planning or not.
So I think, Peter, you're talking about store the Bloom filter as a column in the manifest file, sort of. But because it's big, it could be a separate column file instead of the regular data manifest. Is that what you're?
Yes.
I see.
Just an idea. I haven't went through all of this. Just when I read that, okay, manifest files, then I come to column families, then maybe it is for every file, and then it could be something like that.
I think that's a reasonable approach. Yeah.
Yeah, I can think about it to put it in the manifest level for the Bloom filter. But the key idea is that I'm trying to, prune this early, to prune as many file as possible. But I don't have a benchmark to show what is the sweet point to turn on the Bloom filter.
I think we would want to do that work to figure out like how would you tune the size, how would you tune the false positive rate, and like exactly what it would be. The other thing I would include there is how do you update it? So if we're aggregating Bloom filters, right, you need to know when you create that Bloom filter, approximate NDVs, right? NDV rate of all of the things tracked in that Bloom filter. But you also, like, in order to create the Bloom filter, you need to hash every single value.
Yes.
Right. And if you're hashing every single value, that means you can't take the output of you can't take a Bloom filter itself and go back to the original values, unless you use the exact same hash and you just union the Bloom filters by bits, in which case you really don't know if you're overfilling and causing your false positive rate to skyrocket. So I think that is one of the concerning issues here, is like, if we have to, for every manifest, take the files in that manifest and scan through at least one column in all of those files in order to produce a Bloom filter with a reasonable false positive rate, you know, is just the indexing, is the indexing worth it? Because it seems like a lot of work to maintain the Bloom filter index in that case.
Yeah, I think one of the main assumptions that if we can group the Bloom filter index, we're not unionize them. Let's say group let's say 1,000 Bloom filter index into one Puffin file. We can reduce the number of IOs we need to. Number 5, we need to load to check the Bloom filter index compared to packet footer. For packet footer, let's say we have 1 million data files. After that pruning, we need to 1 million footer IO to check the Bloom filter.
So are you saying, like, for so that, I think that's different than the idea that we're going to have okay. So at that point, we're not talking about aggregating Bloom filter indexes into a larger Bloom filter. We're talking about aggregating Bloom filters and co-locating them in a single file.
Correct.
Yeah, okay. Yes, that would, I think that would alleviate the problem. We would still have, in order to create the index, you'd still have to go, you know, fetch the Bloom filters for a bunch of files.
Yeah, so the Bloom filter is always created per file, but just a storage, whether we distribute in packet footer, we can aggregate them into some Puffin file, maybe align with the manifest boundary, can make maybe the distributed planning more efficient. That's potential approach. I think Peter mentioned about the column file. That's another interesting idea, because in manifest file, we're talking about we're going to have column file. This could be another column file potentially.
So I guess that approach, the approach to basically attach Bloom filters aggregated into Puffin files, like that's just a very different, I think, approach, which is valid, requires, I think, some maintenance to, you know, keep these things. I'm not at all sure that this is in line with the secondary indexes covered by the other secondary indexes covered by this doc, because the other secondary indexes are going to look like a field that you bucket and sort by, and then data fields along with that. Even the vector index, I think, is probably going to be a vector identifier that you bucket and sort by, and then, you know, other fields inside of that. And so I'm not I'm not entirely sure that these two are compatible as the same secondary index concept. It seems like attaching, trying to make the Bloom filters of files available at planning time in a more compact and better representation for IOs is an admirable goal, right? That seems pretty reasonable to me, because it takes care of a lot of the issues of how do we accumulate, how do we maintain these Bloom filters and things like that. But at the same time, I don't think the same mechanism would be used, because that would make the Bloom filter essentially primary metadata in the format. Peter? Okay,
so this is exactly this last point which I was thinking about, that for me, secondary indexes, whatever the type and the form we are storing that, whatever the type and the form, is a secondary data next to the table. So without that, everything should be fine and running. And these are just additional stuff added there during the query. Query planner could decide to use or not use, and during the planning or execution. And I think if we want to store it alongside with the metadata, then probably it is not a good candidate for that. But if we want to store it as any other type of additional data to the table, which we can use it during the planning phase or during the execution phase, then it could be. The only difference here is why I think this approach is not entirely sure where we want to put that, is if we want to align the layout exactly with the metadata layout of the Iceberg file, Iceberg metadata, then it might be a better candidate to store it in the Iceberg metadata directly. But otherwise, if the layout is different or doesn't happen to be the exact match for the Iceberg metadata, then I think it could be a candidate also for the indexes by a different type of indexes, not the type of indexes we have already talked about.
Yeah, I think I agree with what Ryan and Peter said. To me, yeah, seems like the Bloom filter is less of index than like a file metadata. I think sometimes people are talking about maybe it should be managed same as the column stats. It's just a much larger stats than our regular stats. But otherwise, it's actually very similar to column stats.
Yeah, I agree with that. I think for Bloom filter, it is more feasible to put it in the table metadata directly instead of putting it in the catalog as the other index. But I think for the overall structure, probably we also want the Bloom filter works for the create index, the drop index, the author index, along with all the other index.
I'm not sure I understood that last point.
So I'm trying to say that in Peter's overall index architecture, we have something like create index for the table, maybe drop index for the table, and alter index for the table. I think for this index operations, maybe we should make it also work for the Bloom filter index if we decide to have the Bloom filter index. That's the common thing between I think that's the common thing between Peter's index thing and the Bloom filter index.
I see what you're saying. I have a response directly to that. Prashant, did you want to go first though? If you have one too.
No, please go ahead. I have things that we were discussing in the past. So yeah.
I think that's a good point, is like, hey, if we're deciding how do we create and like maintain and track secondary indexes, and this is a secondary index, then we should consider it at the same time. I am again not sure that this is similar enough to a secondary index for all the other use cases that it makes sense to do that. because this is essentially tracking file level metadata in a different way rather than a different way of tracking rows. So I would need to think about that. And again, in order to do that, I think that we would want to know what the Bloom filter index looks like and how it functions enough to decide, is this something that we want to add to the Iceberg spec, or like, you know, create a spec around? And because I think these indexes are probably going to be indexes as a specification. We would want to justify that it does make sense and that it is similar enough to the other index types that we're not like misleading people by saying this is a secondary index. Because like this skipping sort of thing with, you know, false positive, like it brings a lot of complexity into the secondary index discussion if it doesn't function like the other secondary indexes.
Okay, agree.
Sorry, Prashant?
Yeah. So I wanted, so just to resonate on the same point, like it seems like at this point also we have parquet footers, and for the min max we just write it as a manifest entry in metadata, like Iceberg metadata, to have faster pruning or skipping at the time of planning. So I also see it in the same way. One thing I would like to call out is the sizes of the Bloom filter might affect the number of entries we can have per metadata, like manifest file, inside number of rows we might have inside a manifest. So maybe a dedicated column file to store this would be a way to go. So maybe that is an analysis we might have to do, that how much of the Bloom filter size corresponds to that and how much it influences how much things we can fit in inside one manifest, the entries before and after. That's one additional thing I was thinking of. But yeah, totally, the way I also see is that it's an additional file metadata that we are just taking from the parquet footers and just writing it and making it available as part of the manifest for better planning. Just like other thing would be the sizes of the Bloom filters and how much does it influence the number of entries that can go inside one manifest if we keep them in line versus keep them as a separate column file. Like just other chain of thoughts that I want to share.
Just one last comment for that. So since these are not really changing, we probably can just say that, okay, this is the file name and the offset, and it's easier than doing column families or anything around that. File name and offset could, or the file name could be get from somewhere else and just the offset in the given file or whatnot. Just be on an easier side and don't depend on the complicated stuff like column families for the specific stuff. I think we are over time, so definitely we will continue next time. If you have questions, I created Dan created the indexes channel on Slack. Drop the questions there, and I'm there. I'm answering everything and see how this goes through. And thank you everybody for participating.
Bye-bye.
Thanks. Bye-bye.
Bye.
What was it?